Factoring trinomials when a does not equal 1. We've been looking at trinomials to factor where a was 1. By a equaling 1, I mean I'm looking at a trinomial of the form x squared plus bx plus c, where the 1 comes in here. It's my invisible coefficient on my quadratic term x squared. The sorts of trinomials I'm factoring in this toolkit have a coefficient other than 1. So here my coefficient is 6, here my coefficient is 3. When my coefficient was 1, I was able to factor using my diamond. So I looked for the two numbers that multiplied to c and added to b. And then using the solution to my diamond, I was able to just go ahead and write my factors. When a is not 1, I'm still going to use my diamond, but now I have a whole second step. So once I found the solution to my diamond problem, I have to use that to fill in my multiplication box and to work backwards to find my factors. Let's go ahead and look at this example. 6x squared plus x minus 2. Let's write that in factored form. Now, one big difference is that instead of just placing my c in the top of my diamond, now I place a times c. I'm looking for the integers that multiply to a times c, in this case 6 times negative 2, which is negative 12. My b part is the same though. I'm looking for the two numbers that add to b. So add 2, here I have an invisible 1. Think about it for a moment. What two integers multiply to negative 12 and add to 1? I hope you got it. It is 4 and negative 3. 4 times negative 3 is negative 12, and 4 plus negative 3 is positive 1. Now it is really important that you just don't think you're done, okay, x plus 4, x minus 3, like you would have done in the case where a is 1. I hope you can see that x plus 4 times x minus 3 is definitely not 6x squared plus x minus 2. X times x is not 6x squared. So let's forget about that guy. The solution to my diamond problem gives me some really important information, but it doesn't just give me the factors. I'm not done yet. I have to use my information from my diamond, as well as some information from my original trinomial, to fill out the inside of my multiplication box. Once I have the inside, I'm going to work backwards to figure out what the outside was, what the two binomials are that multiply to that inside. First step, I take my 6x squared term and my negative 2 and put those into my multiplication box. So my quadratic term goes in the upper left, 6x squared, just my original quadratic term. And my constant from my original trinomial goes in the lower right, negative 2. The other two parts of my box that I need are my two x terms. My two x terms that when I combine like terms will give me my middle term here. This is where my diamond problem comes in. So my 4 and my negative 3, 4 and negative 3, it doesn't matter in which order you write those in the box. Those give me my coefficients on my two x terms that when I simplify, when I combine like terms, will give me the positive x. So if you look at the inside of this multiplication box, I have 6x squared plus 4x plus negative 3x minus 2, and that's going to simplify to my original trinomial. What I need now is the binomials on the outside that when I multiply will give me the inside of this box. Now this is not just a guess and check situation. There's a really great strategy to use to find the outside of my box that multiplies to give me the inside of my box. What we're going to do is we are going to focus right here to start with what we're placing on the top left outside part. So we're going to figure out what two factors multiply to give me 6x squared. And the way we do that is we find the GCF of this row and the GCF of this column. The GCF of 6x squared and negative 3x is going to be the GCF of 6 and negative 3, which is positive 3, and the GCF of x squared and x, which is x. So when we're working backwards to find the outside of this box, we're looking for the GCF of the first row. And now I can similarly find the GCF of this column. GCF of 6 and 4 is 2. GCF of x squared and x is x. But I can also just think, what times 3x gives me 6x squared? That gives me the same answer, 2x. So GCF of 2x, or what times 3x gives me 6x squared, and that's 2x. Now I'm pretty much home free. I'm going to think, what times 3x gives me the inside of my box, negative 3x? So think about it for a second. What times 3x multiplies to give me negative 3x? The answer to that is negative 1. For this side of the box, what times 2x gives me 4x? The answer to that is 2. So 2 times 2x is 4x. 2 times negative 1 is negative 2. So now I have the outside of my box. I know this outside multiplies to give me the inside, and the inside simplifies to my original trinomial. So I'm done. In factored form, 6x squared plus x minus 2 is 3x plus 2 times 2x minus 1. I can check that with the distributive property. 6x squared minus 3x plus 4x simplifies to x minus 2. But if I did my box right, I've already checked. My box is one way of multiplying, and 6x squared plus 4x minus 3x minus 2 simplifies to my original trinomial. Let's look at another example. All right, 3x squared minus 2x minus 8. I need to fill in my box to start with. Again, I'm not just writing negative 8 here. I'm multiplying to a times c, to negative 24. So multiplying to negative 24, and then still adding to b, adding to negative 2. So think about that for a second. What two integers multiply to negative 24, but add to negative 2? Do you have it? The answer is negative 6, positive 4. So negative 6 times positive 4 is negative 24, and negative 6 plus 4 is negative 2. Diamond step done. Again, we're not completely done because x minus 6 times x plus 4 definitely does not multiply to this trinomial. I need to fill out the inside of my box and then figure out what outside multiplies to that inside. I'm going to take my original quadratic term and place it in the upper left, 3x squared. My original constant and place it in the lower right, minus 8. And then the inside of my box is obtained from the solution to my diamond problem. So this gives me my coefficients on my x terms, negative 6x and 4x. And notice, this is just what I want. Negative 6x plus 4x adds to negative 2x. Now, just like before, I'm going to focus on finding the outside of my box, starting with this number and this one, or this term and this term. So let's go ahead and look at the GCF of this row. There's no GCF of the numerical factors of those coefficients. 3 and 4, they don't have a GCF other than 1. But x squared and x do. So my GCF of my row is x. GCF of my column, 3 and negative 6, is positive 3. And then x squared and x is x. And then I just make sure that x times 3x does multiply to 3x squared. Like last time, I could have just found this one singular GCF and then thought, what multiplies by x to give me 3x squared? 3x. I could have also found the GCF of the column, 3x, and then thought, what multiplies by 3x to give me 3x squared? X. Now I'm going to find my other two terms of my factors by thinking, what multiplies by x to give me 4x? What do I need to multiply by x to give me 4x? The answer to that is x. So x times 4 gives me 4x. What times 3x gives me negative 6x? That is negative 2. So x times 4, 4x. Negative 2 times 3x gives me negative 6x. And then I need to check, I don't know if I mentioned this above. Did I check that 2 times negative 1 was negative 2? I need to check that this final multiplication works, and it does. Negative 2 times 4 is negative 8. So I'm done. I'm going to write my factors in this order. 3x plus 4, doesn't really matter, times x minus 2. I can use the distributive property to check that factoring. 3x times x is 3x squared. Minus 6x plus 4x simplifies to negative 2x. And then minus 8. But even if I asked you to check, you should say, I don't need to. I've already multiplied using the box. And that shows me that 3x plus 4 times x minus 2 does in fact multiply to my original trinomial, 3x squared minus 2x minus 8.